Hello everyone, welcome to my channel. Today we are going to look into another Leetcode problem, that is the threesome problem. So this is also a very frequent asked interview question, and this one is a sequel of the classic two-sum two problem. So if you guys haven't looked into that, I'll suggest to please solve that first. I have a solution posted on my channel for that as well, so I'll post a link in the description box. You guys can check it out. Okay, so what does the problem statement says? So it says that we are given an array of numbers, and we have to find the combination of three numbers that sums to 0. So in this case, we are given this array, and the output of this array will be -1, 2, that makes 0, then -1, 0, and 1. But there is a catch. There might be a point where we'll get the duplicate combination, but we have to only return a single combination, not the duplicate values. So let's see how we can achieve that. So let's look into this example we have here. Uh, First of all, this is the given array that we have, and the first thing that comes in the mind is we can use a brute force solution for it. And brute force solution goes like, we can add 3 for loops and iterate through each of the element and check if the combination is 0, and if it's 0, we'll add it to the result and return the result. But in this case, it might happen that when we are iterating through the loop, we might have the combination as duplicate. For example, in the first iteration, we might get like -1 and -1 and 2 as one combination. Then when we come to this position here, we might again get a combination of -1, -1, and 2. That makes 0. So that is the problem with the brute force solution here. So in this case, if we consider this array, what is the approach that we can follow? So the thing is, to solve this type of question, we can do a sorting of this array. Let me tell you why we need this sorting array. Okay, let me show you. For -4, the sorted array will be -4, comma, -1, comma, -1, comma, 0, comma, 1, comma, 2. So this is the final array that we get. So like I said, if we sort this array, we can check the adjacent values of this array, and we can say, oh hey, this one is already, we have computed the value for this. For example, if we get the combination of -1, -1, and 2, and in this case -1, -1, and 2, and it equals to 0, like -1, -1, and 2 is equals to 0, and we go to the next loop again, and in this case again we get a -1. So we know that already we have computed for this value, and again the combination will be same if we go again with that. So it will be the duplicated values will be returned in this case. So we don't want that actually. So that's the reason we sorted the array, so that makes our work easier. So let's see how we can do this after this sorting is done. In this case, we'll simply need, let me just copy paste this part, this array of ours. Oops, I think it's the same one. Okay, let me do it again. This is -4, comma, -1, comma, -1, comma, 0, comma, 1, comma, 2. So in this case, we'll use the two-pointer technique. So one will need, since we need 3 numbers, we'll take an outer loop as a for loop to consider as one index here. This will be a for loop for our index, and then we'll use the two-pointer technique, similar we did in the two-sum, and we'll set the pointer here first to the first index and the end position as the second pointer. So here when we have -4, -1, and 2, does it make 0? No, it gives the output as -3. So we'll check if -3 is less than 0. If -3 is less than 0, then we need to make the output as higher. So in that case, we'll simply increment our left pointer or the start pointer to the right. So now let's see, even in this solution we have like duplicates, right? So we know that we have computed the value for -1, so we'll simply skip this and we'll move our pointer again to the right index, to the right. Okay, so again we'll calculate like -1, -4, 0, -4, 0 and 2. Does that make 0? No, it makes -2. So in that case, again it's lesser than 0. We'll move our left pointer to 1. Okay, so in this case again we'll check 1 plus 2 is 3. We are not getting combination in this particular iteration. So next, in the next iteration, we'll simply move our pointer to here. Our for loop goes to the first index and we start our pointers from here. Okay, and we keep on checking until we get the combination that sums to 0. So this is the whole logic that works. I think let's start coding and you guys will get it better how it works. Okay, so let's see how we can code this out. So to check that our nums always has a value, we use a guard statement here, else return an empty array. Okay, then we'll need a result to store the values of the combinations, and it will be a result of int. Then we'll like I said, we have to sort the array so that we can eliminate the duplicated value here. So sorted nums equals to nums dot sorted for I is an index, and we'll take some value here in sorted nums dot enumerated. If you guys know, enumerated gives us both the index and the value in the array. Okay, so if I is greater than 0 and value equals to sorted nums I -1, then we don't have to do anything, we'll just continue. Okay, so if I is already our index is greater than 0 and value is equals to sorted nums I -1, then we don't have to do anything, we have to just continue. And we'll now use a start pointer I plus 1. Okay, so this will be I plus 1, and we'll need an end pointer that will be sorted nums dot count -1. Okay, so this will set the index to first position and this will set the pointer to the last position. Okay, and we always have to check while start pointer is less than end pointer, and we'll get the total of all the three, like total of pointers from the index of the for loop, and we'll check if its sum is 0. Sorted nums of start pointer plus sorted nums of end pointer. So if the total, so this is where we, from the while loop, where we are applying the two pointer technique, from the to some second version. So you guys need to go and check that first to get to know how this actually works. End pointer is so if the total is greater than 0, then we have to move the end pointer to the left. Okay, That means we need the value that is to be lesser than the value that we currently calculated. Else if is less than 0, then we have to increase our start pointer by 1. Okay. In any case, if it's equal, but we don't have to stop, right? We have to keep on looping, keep on increasing, keep on finding other combinations as well. Okay, so if we find it the total as 0, we'll append it to our results. Sorted nums of I, comma, sorted nums of start ptr, and comma, sorted nums of end ptr. Okay, and we also have to increment a pointer. It doesn't matter whichever pointer we increment. So the output will be the same. Okay, so I'll increment the start pointer here by 1, and while I'll use another loop here, nums of start pointer equals to sorted nums of start pointer minus 1, start pointer is less than end pointer, keep on incrementing the start pointer. So this is the condition to check the duplicate value. So if we have a duplicate value and the sorted we already have seen the value like start pointer and start pointer minus 1 has the same value, then we'll keep on increment the start pointer. Okay, and once this is done, we have to return our array after this for loop. Okay, return our result. Okay, let's see if this works. I know I'll do some silly mistakes. Okay, so this thing passed. Let's see and submit. Okay, so it's pretty good. So that let's talk about the time complexity here. So since we are using a sorted sorting logic, as you guys know, has already a sorting a time complexity of O of n. Also we are using a for loop and a while loop, so we are also getting a big O of n square. So the final time complexity is big O of n square here. Okay, and since we are not using any space here, it will be the space complexity will be O of 1. But I think sorted one uses O of n as a space complexity, so this might be the worst scenario will be O of n as a space complexity. So that's it for today's video. I hope you guys like it. Please do like, share and subscribe to my YouTube channel, and happy coding.